Please sit down. Okay, class. Before I start the lesson, I just want to tell you about this upcoming Math Olympiad. You know what a Math Olympiad is? If you are aware of it from your time in Sec 2, or some of you, okay? Basically, class, it's like a competition that many schools in Asia are participating in. So this year it is open to all of us also. If you are interested to sign up, please let me know after the lesson. Do you have recess after this? No. Oh, you have a test. Okay. What time is the recess? 11:55. Okay. If you are interested in this, you may come and see me at 11:55 and I will register your name for it. There is no training. You don't have to come to school early on Tuesday morning to sit for some extra lessons. Nothing like that. Just register. If you are selected, go for the test. Okay? So some of the details for this competition, okay, I shouldn't say test, some details, I'll just put it on the board. No, no need money. Free. So might as well, okay? So this is held on 3rd April, 3 to 5:30 p.m. Okay. Next one is SMO. This over here is SASMO, SASMO. For Singapore and Asian schools Math Olympiad. Can you take a guess what the SMO stands for now? Singapore Math Olympiad. So this time for SMO, you will not be competing with other Asian schools. So which one do you think is more prestigious? Yeah, this one. This one over here is more prestigious. But SMO is also prestigious. So depending on your results, you'll be given an award. They are. Yes, some of you have taken it before in Sec 2 already, so you are aware. Just go and find out from your friends what this is about. Reminder, if you are interested, you let me know during your recess time today because by tomorrow I have to submit the names already. Alright? The dates and the times are written on the board. Okay, next thing. Yesterday we stopped at Try It 21, right? Have you all tried it already? You should have. Please take it out. Okay. Do you need help for Try 21? Or who needs help? Raise our hand, please. Who doesn't need help? Raise our hand. Who doesn't need help? And for the rest? Okay, let me try one more time. I need your response so that I can make a judgment whether I go through it or not. Who needs help for this question? Raise our hand. Okay, who does not need help? Raise our hand. Okay, now I'll just go with the majority. For those of you who did not raise our hand, I assume you're just too shy because you've already done it. You got it right. Okay, if you need help, look for me after this or look for our friends for help. Okay, so we'll move on to the next topic. 2.7, sketching the graphs of quadratic functions. Before I start, I would like you to copy this down on page 65. Okay, because during the lesson, I will be referring to these 4 points frequently. I will explain what they mean. Just copy down x-intercept, leave a blank, y-intercept, leave a blank. Line of symmetry is x equals to, leave a blank. Blank point is open bracket, blank, comma, blank, close bracket. Okay, we'll fill in the blanks later on. Okay, copy this down. Done with your copying? In lower sec, we learned how to sketch some graphs. Which graphs have we learned how to sketch? You learn quadratic? You learn quadratic? Oh, okay. Okay, but something more basic. Linear. Okay, so straight lines. What is the graph of a straight line? What is the equation of a graph of a straight line? Y equals to mx plus c. You see y equals to mx plus c, we know that it is a straight line, right? Okay, today we are still going to be talking about the graphs of, we're still going to be talking about quadratic functions. So quadratic functions, as we know, it is going to look like this. ax squared plus bx plus c. Now today, if I give you something like this, okay, so let's say we have 2x squared plus 5x minus 10. For example, can we sketch this?
Yes.
Can we sketch this?
Yes.
Yes? What is your horizontal axis? Horizontal axis, what are you going to label it as? Horizontal axis. You know, you're supposed to draw a vertical axis and a horizontal axis, right? Okay, horizontal axis will be x. What about your vertical axis? Are you sure? I didn't say y is equals to this. So, can I sketch this? No, I can't. This is not an equation. Is this an equation? No, there's no equal sign. I didn't say that y is equals to this. However, if I did say, oh, okay, y equals to all these things, can you sketch it now? Yes, you can. This will be a y axis, then we will have our table of values, x and y, we'll fill in the blanks, and we will be able to sketch a graph. We'll be able to plot a graph, right? Okay, so that is for some basics on whether a graph can be sketched or plot or so on and so forth. Okay, hang on, my tablet seems to have some issues with the pen. I'll restart it first. Later on, I'll show you my favorite website, my favorite mathematical website that I encourage all of you to use. Okay, it is called Desmos. Any of you heard of this before? No, okay, it's simply called Desmos.com, okay? Basically, it is a graphing website. You key in the equation and it will show you the graph. Okay, I'll continue to let it load. I'm going to be referring to this website for checking purposes. Okay, we are going to be learning how to sketch. Then we are going to go to this website to check whether our answers are correct or not, our sketches are correct or not, you can use this even when you progress on the JC University. Okay? It's going to be very, very useful for you. Now, so earlier on I mentioned that linear graphs y equals to mx plus c, we know that it's going to be a straight line. Okay? So if vertical axis, horizontal axis, y equals to mx plus c. If I have quadratic equations, y equals to ax squared plus bx plus c, it is no longer going to be a straight line. It is going to be a curve. How do we draw a curve? Well, a curve can look anything as long as it's not a straight line. For example, like this, like this, like this, like this. All these are curves, right? But for quadratic, we only have two options. If it is an equation that looks like this. Yes, I know the word that starts with P. What's the word? Parabola. Parabola. Out of all these, 1, 2, 3, and 4, which one is a parabola? Okay, the second one is a parabola. How do we describe this parabola? What are some features you can tell me about this parabola?
2y intercept.
Huh? What?
2x intercept.
Okay, so this is a parabola. Tell me some features you can see. I heard 2 what intercept? 2x intercepts. 2x intercepts? Not necessarily. Wow, this is a very interesting answer. So you mean sometimes we can have 2x intercepts and sometimes we don't? Okay, let me see. X intercepts means that the graph will intersect my x-axis. Right? Okay. How many intercepts do you see? Okay, I've got 2x intercepts. Is it possible to have no x intercept?
Yes.
How? Where should I draw my x-axis?
Below.
Below. You mean like this?
Yeah.
Okay, so this is no x-intercepts, right? How about if I draw it this way?
No, the line continue there.
Are there any x-intercepts in this case?
Yes.
Yes or no?
Yes.
Haven't drawn bigger the graph.
You draw longer then.
What should I draw longer?
More values.
The ends of the parabola. Okay, so this is a feature of the parabola. A parabola continues on and on forever. Okay, in this case, this is known as a parabola that opens upwards. Understand? This is a parabola that opens upwards. It goes on and on forever and ever. But due to the lack of space, I can't draw all the way up. So eventually I stop. Okay? So, but one thing you need to know is that it just keeps rising above all the way up. Okay? To infinity. Parabola opening upwards. But if I have two intersection points, I've got no intersection points. Is it possible to have one last case?
Yeah.
What is the last case? I've got two intersection points over here, 1, 2. I've got no intersection point. Is there one last case I can possibly have? Yeah, you're talking about the shape of the parabola, but I'm talking about the position of the x-axis. Yes.
Is it one intercept?
Is it possible to get one intersection point? How? Where should I draw my x-axis? Turning point. Wow, I'm hearing a lot of words, many words that are very important to this topic. Okay? So over here it touches, listen to the words that I'm using, it touches my x-axis at one point. We can also call it as intersecting the x-axis at one point. Okay, and this point over here is known as the turning point, also known as the minimum point. Okay, out of these two, turning point and minimum point, which one do you need me to explain? Both the same one. So if I ask you, why is it called a turning point? Can you explain? Why is it called a turning point? What do you mean by the graph turns? Okay, I hear another thing, line of symmetry. Let me just put it down before I forget. Okay. So, obviously everybody knows that you can tell that this is the minimum point, right? It is lowest at this point, it's called a minimum point. But I also heard some say it is a turning point. Why is it called a turning point? In what sense does the graph turn?
The gradient of the
Gradient? I think you're right. Okay, I'm going to draw a tangent line. Okay, so over here, these are tangent lines. It follows the curvature of the graph. Okay, notice that it is pointing downwards, pointing downwards, pointing downwards. When I go lower and lower, you can see that it starts to, the change is more obvious, right? when it comes to this particular point, my ruler is horizontal. It is always straight. Come on, it is always straight. Huh? You meant horizontal. It is horizontal over here. Then what happens at this particular point in time? It turns. It changes direction and it goes up. Okay, so this is called a turning point. Okay, alright, so that's the minimum point in this case. Okay, next, line of symmetry. Where's the line of symmetry?
The turning point.
Ah, okay, it cuts through our turning point. So I can always draw a line of symmetry like this. Okay, if our parabola looks like this line of symmetry, is it a perfectly vertical line?
Yes.
Perfectly vertical, right? How do we describe vertical lines in
Y-axis.
Y-axis is an example of a vertical line. How else do we describe vertical lines with equations? X equals to something, yes. X equals to something.
No, that's Y.
It can be anything. Okay? This value could have been 5. Then this will be X equals to 5. What is that? Turning point, just like our minimum point, consists of a pair of coordinates. The X value, in this case, it is 5, and the Y value, which I haven't shown you yet. In this case, if it is on the x-axis, it will be 0. Okay, so this is it about the line of symmetry. It will pass through our minimum point. Okay, so far? Okay, anything else that we need to take note of? I asked you to copy down a few things, right? X-intercept, Y-intercept, line of symmetry, and a blank point. Then you have a set of coordinates to fill in. Basically, I've covered everything. Besides a parabola looking like this, I can also have a parabola looking like this. Okay? What should I call this parabola?
Parabola opening downwards.
Parabola opening downwards. Easy? Okay, some people remember it as a smiley face and a sad face. You can use those to help you remember, but just know that the actual way, the correct way of saying it is parabola opening outwards, parabola opening downwards. As the name suggests, it will just keep opening forever and ever. Just keeps extending. Similarly, I can also have 2 intersection points with the x-axis, 1 intersection point, or no intersection point with the x-axis. Okay? I also have line of symmetry, a vertical line. It is still going to be x equals to something. Okay? I will still have a turning point. This time the turning point is called a maximum point. Okay? Any questions about parabolas? Then I'm going to show you common mistakes first, before you attempt to draw. Before you attempt to sketch. Okay, look at this. This one over here versus the other 2 graphs that I sketched. What do you think? Okay, what else? Okay, sharper pink. The sides look like straight lines. Looks like a mountain. So the other one would therefore look like this, right? Okay, which ones are parabolas? 1, 2, 3, or 4? 3 and 4 are parabolas. What's wrong with 1 and 2? What is so wrong with it? Then you look at it and you can tell me, hey, that's not a parabola, and these 2 are parabolas.
Actually,
It is? Is it a parabola? I didn't use specific for any of that. Yes? No. Okay. Most of you are right in that these 2 are not parabolas because of the sides. They are mostly straight, right? This is not a curve. These are mostly straight lines. Over here, straight lines. Straight lines, straight lines. So some imagine that, wow, this one is very sharp. Looks like a mountain. So these are examples of non-parabola. Okay? Whereas a parabola should have its gradient changing. Earlier on, I used the ruler and I shifted it, right? It should be curving, it should be rotating and turning all the time. Whereas if I place a ruler here, it will be mostly straight. Then over here, I make the turn and then I go down. Okay, so that's the difference between that's one of the differences between a parabola and a non-parabola. One more common mistake I want to make it known to you. Like this. Is this a parabola? Why isn't it a parabola?
it looks like
Okay.
So remember what I said about the names of a parabola? What's the name of this parabola again? Parabola opening upwards. Parabola opening downwards. What will you describe this?
Inwards.
Parabola opening inwards. So you see, if I extend, it is going to go inwards. Okay, so I don't want all these turning inwards as well. Okay, similarly, they should not be vertically upwards. It should always be opening. So this is also not a parabola. Okay, it should always be opening. Okay, hopefully this will be resolved in 1 minute. Now I want you to look at your textbook on page 65. We see two examples of parabolas. And they also indicated the turning points and the line of symmetry. So basic stuff that you have already learned in lower set. Okay, now on page 66, this is a class activity that I would like you to try with my website Desmos. We see that there are many graphs being drawn on page 66 with all the different equations. Okay, but take note that all the equations, they are of the form. What is the form like? Y equals to x minus h squared plus k. Okay, this one over here that I've underlined. Is it familiar to you? When have we seen this?
Partial.
No partial fractions.
Square.
This one over here. What is this for? What square? What square? Okay, completed square form. This is the completed square form. And whenever we see a question like this, asking us to sketch this, there are a few things you need to think of, and they were found in what I asked you to copy now. X-intercept equals to y-intercept is, line of symmetry is, minimum of maximum point is. We need to fill all those blanks before we can start sketching. So now we are going to try and explore the website first. Okay, we got it up. So, just key in Desmos. Okay, the very first link, beautiful free math. Okay, start graphing. We're going to start graphing. Red button. So you see, over here I get to key in my equation. What should we key in first? In our textbook, they require y equals to x squared, right? So what does the graph look like? Y equals to x squared. Oh, this is my graph. What is this shape? Parabola, opening upwards. Okay. So now with this graph, can you tell me what the y-intercept is? What is the y-intercept? 0. Can you fill in the blank in your table? The very first blank on page 66, the y-intercept. What do it? Because you will need this relationship. We want to discover something. Okay, then let's check whether everything else is correct. Line of symmetry. We all know it's going to be a vertical line. In this case, it coincides with our y-axis. Coincides with the y-axis. What is the equation of the y-axis? 0 is not an equation. What is the equation of the y-axis? No? Okay, let me show you. X equals to 10. What does the graph look like? In blue color. X equals to 10 over here. Okay, this is an equation of a straight line, a vertical line, y equals to 10. What about the graph of y equals to 3.3? It's going to look like this. Okay, so these are all vertical lines. They are equation of vertical lines. Over here I've got a slider that I can move left and right. So I will move my vertical line. Okay, so what exactly is the equation of the y-axis? Can you tell me before I reach there? X equals to 0. Can you see that? Okay. Oops. Okay, use my mouse. Okay, I'll just type this. Yes, x equals to 0 is my vertical line. Okay, and that is my line of symmetry. So turning point is 0, 0, as we can all tell from here. And we notice that from our drawings just now, it seems like the turning point always lies on our line of symmetry. Okay? And the final column, is it a minimum or maximum point? This one here, minimum or maximum? Minimum, okay, good. Let's try for the second case. Y equals to x squared minus 4. Y equals to x squared minus 4. Okay. Now I've got a green graph over here. Can you fill in the blanks first before we talk about it? Y-intercept. What's the y-intercept? Over here. Okay. Line of symmetry. What's the line of symmetry? Line of symmetry. I need a line. How do I describe this line? X equals to 0 is the complete answer. If you tell me 0, you are not going to get the mark you deserve. Okay? Is x equals to 0. That is an equation of a line. Now next, the turning point in this case will be 0, negative 4. And final column, it is again a minimum point. Okay? Second row, fill it already. Okay, the y-intercept in this case is negative 4. Y-intercept is negative 4. Line of symmetry, x equals to 0. Turning point is 0, negative 4. And it is a minimum point. Okay, tell me the differences between the red graph and green graph. Visually, what do you see? What's the difference between a red and a green graph? How are they different? Minimum point is lower. I hear the y-intercept is also different. Am I right to say that the red graph is shifted downwards?
Yes.
To get the green graph? Shifted down by how many units?
4.
Why 4?
Negative 4.
Oh, so are you suggesting that it might be due to the negative 4 in the green graph that caused it to be shifted downwards?
Yes.
Yeah, I think you're right. Because if you think about it, for the red graph, for any x value that I have, I will have a corresponding y value, isn't it? For example, when x is equal to 0, y equals to 0 for the red graph. When x is equals to 1, y is equals to 1 for the red graph. Now if I change it for the green graph, when x is equals to 0, y is now 0 minus 4. So originally it was 0, now it is reduced by 4. When x is equals to 1, which is somewhere here, when x was equals to 1, y was equal to 1. But now, in the green graph, it becomes 1 minus 4. So 1 minus 4, we get negative 3. Shifted down by 4 units again. So the red graph is now shifted downwards by 4 units to get a green graph. And it happened because of the minus 4 in our second equation. Okay? The line of symmetry didn't change. Still the same one. Make a guess. What happens to my third graph? Y equals to x minus 3 squared plus 2. What do you think will happen?
Higher.
Higher. Do you think it's still going to be a parabola opening upwards or downwards?
Downward.
Opening downwards.
Upward.
Then we must have a reason why. We must be able to explain why. The x squared is positive. What does that mean? The x squared is always positive. Can you have a x squared value that is negative? Can we have an x squared value that is negative? Cannot. Yeah, so it's always positive. So what did you mean? Yeah, I know what you're trying to say, but I'll come to that in a while, okay? I'll just show you this graph first. Y equals to x minus 3 square plus 2. Okay, now the purple graph. I heard that some of you said it's going to be higher. Yeah, you're right, it's higher. It is higher because of the constant at the back, the plus 2. Okay, the plus 2 make the graph go higher. But do you notice that it also shifted in another way, in another direction? How did it shift? Left or to the right?
Right.
And shifted to the right. By how many units? If I were to compare, for example, these two graphs. How many units did it shift to the right? I will zoom in for you. Okay, how many units did it shift to the right? 3 units. 1, 2, 3. You shifted to the right by 3 units, you shifted up by 2 units. Oh, we got the part about shifting up correct already. It is due to the plus 2 over there. So what caused this graph to shift to the right by 3 units?
-3.
So make a guess. Just a guess will do.
-3.
Okay, it seems like because there's a -3 inside the perfect square, that caused it to shift to the right by 3 units. Okay, so let us just record down our observations first. The y-intercept in this case is over here, 11. Let's record this down. Y-intercept is 11. Line of symmetry is, in this case, x equals to 3. Record all these down because it's too small for you to see. Now the turning point is 3, that's the x coordinate. 3 and the y coordinate is 2. So 3, 2 for our turning point. Next, this is again a minimum point. Who needs me to go repeat any of these blanks? Anybody? If not, I'll go to the next example and we record our observations and we see what we can discover from that. Y equals to x plus 5 square minus 3. Okay, now black graph. Okay, what do you notice if we were to compare the red and the black graph? Red and black graph. How did it change? It is shifted to the left. By how many units this time? Let's see. This x coordinate is -5 over here. Okay, so it appears to be shifted to the left by 5 units. Can you make a suggestion or a guess why 5 to the left?
Positive plus 5.
Why 5 to the left? Where did this magical 5 come from? It looks like it's inside the bracket again. Looks like there's some effect when I put an x plus something or x minus something and then I square it. It seems to have the effect of shifting the graph to the left or to the right. And then what about this -3 at the end of it? What did the -3 cause? How did the -3 cause the graph to change? Move downwards by how many units? 3 units. Okay, excellent. So now let us fill in the blanks. Our y-intercept in this case is black graph 22. Y-intercept is 22. I've got my line of symmetry. Line of symmetry, we saw that it is x equals to -5. Okay, that's my line of symmetry. I've got my turning point that is at -5, -3. And then I've got my turning point, again it is a minimum point. Okay? Yes?
For the y equals x minus 3 bracket square plus 2, right?
Yeah.
What is the y-intercept?
The y-intercept over here is 11. Okay, so far have you filled out your table already? Then we've got one last line, right? We've got one last line. That is the general form. Y equals to x minus h squared plus k. Can you look at all your values before that and you make a suggestion? What do you think you should fill out for the y-intercept, line of symmetry, turning point, and whether it's a minimum or maximum point? Okay, I'll give you 2 minutes to think about it. You may discuss in your pairs or in trees. Make use of your recordings, the observations for the graphs I've shown. Come up with a general case.
I'm not so sure about this one.
Okay, I'll go through it. Yes?
Level of this 11 is okay.
Oh, sorry, I made a mistake. Okay, I see some of you moving on to the next page already. Which should imply that this portion is not a problem, huh? Great. Let's try to understand why we get these results from the graph. Because earlier on when I showed you all the graphs, I didn't really explain to you why. I didn't explain to you why the graphs look like that. But now let's think about it from another point of view. Y-intercept. You've learned y-intercept for straight line graphs. The y-intercept is simply where your graph cuts the y-axis. When does a graph cut the y-axis? Okay, it is when x equals to 0. So this is universal. Just take note of this. This implies that x equals to 0. Whenever you are told to find the y-intercept, it implies that x is equal to 0. Let us see whether this is true or not. When x is equal to 0, y will be equals to 0. Make sense? Okay. When x is equals to 0, y will be equals to 0 squared minus 4, and I get negative 4. Okay. So that's how I get a y-intercept. When x is equal to 0 over here, 0 minus 3, I get negative 3. Negative 3 I squared, I get 9. 9 plus 2, I get 11. This is y. We've got a y-intercept as 11. Next, 0 plus 5 is 5 square, 25 minus 3, we get 22. So this is how we obtain all of our y-intercepts. What is therefore supposed to go into this blank? Negative h squared plus k. Like this. So we might as well write it as simply h squared plus k, right? Okay, h squared plus k. Do I need to memorize this? No need. No need to memorize. You've already learned how to do it. It simply means that x is equal to 0 over here for the y-intercept. Never go and memorize this. It is just a general form. Okay, now, line of symmetry. We've got line of symmetry over here. Oh, apparently the first one is x equals to 0. The second one, x also equals to 0. Third one, x equals to 3. Fourth, x equals to negative 5. How do you think we obtain this line of symmetry? From this square term, let me highlight it for you. Are you referring to this portion? Okay, then how do you get for example, how do you get this? X equals to negative 5. What did you do to get x equals to negative 5? If I want you to count it for weight. How will you know? By looking at the equation that, hey, the line of symmetry must be x equals to negative 5. Do you see any pattern? What is the pattern that you see? Opposite. Okay, plus 5 becomes negative 5. What else? The negative 3? Oh, then it becomes 3. What about the x over there? No, that looks a little strange, isn't it? How about I rewrite it? This x squared, let me rewrite it as x plus 0 squared. How about this? Does it help you decide the line of symmetry? If I rewrite my x squared as x plus 0 squared, what is therefore the line of symmetry? X equals to 0. Does it make a difference if I put it as x minus 0? How about I put x minus 0 and I square it? I'll still get x squared, right? So what is the line of symmetry now? It is still x equals to 0. So we see that actually I can rewrite this one over here as x plus 0 if I like. And I will therefore obtain my lines of symmetry. So can you tell me what goes inside here? What is the line of symmetry here? H, you're right. Okay. What about the turning point? How do I obtain the turning point? Turning point consists of a pair of coordinates, the x value and the y value. Let us consider all the x values first. Okay, I'll highlight them. What do you notice for all these x values? Do you notice anything about them? Are they very familiar? Do they look repeated? Have they seen them somewhere? Yeah, you see them all here. So, can we fill in the x coordinate of our turning point already?
Yes.
How much is it? H. Okay. What about the y coordinate? Constant, sure?
Yes.
Oops. So you seem to be suggesting that the y coordinate is simply this value. Is that what you're saying? Why would that be so? Why would all these y values be that particular constant at the end? Why? It looks like there's a pattern, and our job is to find out why is it like that. Is it the y-intercept? No, it's not the y-intercept. The line of symmetry is from the x coordinate. So why is it that it's so strange? All of the y coordinates, they appear to be that last constant that is outside the square. Any suggestions? Is it a coincidence? No, it is not a coincidence. My job is to find out why. X and y coordinates, they come in a pair. Whatever value of x you have will determine your value of y. Agree? Right? That is how it works. That is how our coordinate geometry works. Now what happens if x value is 0? You substitute it back inside, what do you get for y? 0. Okay, that's why you get y value equals 0. Let's look at the next one. When x is equal to 0, which is found from the line of symmetry, what do we have for y? What do you have for y when x is equal to 0? Negative 4. That is how I get my y value. Let's look at the next one. When x is equal to 3, which is on our line of symmetry, when I put it back into the equation, what do I get?
0 plus 2. 0 plus 2.
What do I get?
2.
0 square plus 2, right? Is it a coincidence that I get 0 square? Earlier on, I also got a 0 square, then I get 0 square minus 4. Third case, I get a 0 square plus 2. 0 square plus 2 is simply 2. Okay, that's how I get a 2 over here. What about the next one? I've got a negative 5 over here. When I put this negative 5 back into my equation, what do I get?
0 square minus 3.
0 square minus 3. Why is it always 0 square, 0 square, 0 square? Because you made it that way. Because you made it that way. We see our line of symmetry over here, the x values coincides with our x coordinates for our turning point. I want to find the y value. The y value happens when I have my x value. The x value came from the line of symmetry. So what we did over here, remember you were telling me that, it is actually the, how do I get negative 5? It is the opposite of that 5. You know, you were saying that it is the opposite of 5. I see a 5, I change the sign, it becomes negative 5. I see a negative 3, I change the sign, it becomes a 3. You know why? Why are you changing the sign? What is your objective? Your objective was to make all these equal to 0. Okay? Now, if all these becomes 0, so my x value is h. This is now h. h minus h squared plus k. What do you think I'll get? K. Okay, so over here I'll just put it down as minimum first. Then the question is, why is it that I am always trying to make all these be equal to 0. Why is it that this must be 0, 0? Why do all these need to be 0? In order to get our turning point. In this case, they are minimum points. Okay, let us consider from the graph again. Okay, start with the basic one. Y equals to x squared. Minimum point over here is at 0, 0. Okay, I've got all sorts of x values. My x value can range from negative 1 million or even further back, all the way until 10 million, whatever it is. X goes left and right. My y values will change according to the x values. So for example, look at the set of coordinates over here. As I move my cursor along the graph, my x values increases. The y value drops. Okay? For those of you who can see the number, but you can just follow the dot, okay? As my x increases, my y decreases, okay? And that keeps happening until I reach the turning point. Now my x continues to increase, but what happens to my y value? My x value will now increase. Okay, one more time. From the left hand side, x decrease, x increase, y decrease. Go to the turning point, x continues to increase, but this time y increases. There is therefore a minimum point over here. It happens at 0, 0. Okay? Looking at the second, let's look at this one over here, the green one. Y equals to x squared minus 4. Again, I want to look at near the turning point. As x increases, y decreases until this point. Then x increases, y increases. That is where I have a turning point of 0, negative 4. The minimum point happens when x is equal to 0 in these two cases. Okay, and now for the next one. I want the minimum point for the purple graph. Again, now we'll go through the same exercise. X increases, y decreases. Okay, until we come to this particular value of x, which is 3. Then my x value increases, y also increases. Why? Why does it happen at this point? Y equals to x minus 3 square plus 2. I'm going to focus on this now. Want to find the minimum point? You are free to choose any value of x you like. My objective is very simple. I want the smallest possible value of y. You can choose any value of x you like. Okay, I want the smallest value of y. That's why we call it minimum point. Throw me some random values of x. 3. Why you want to choose 3? Okay, let's try 4, okay? Let's try 4. When x equals to 4, y equals to 4 minus 3 square plus 2, which gives me 3. Okay, let's try some other value of x. When x equals to 1, y equals to 1 minus 3 square plus 2, which is negative 2, 4 plus 2, 6. Okay, let's try some other values. Okay, you want to try 3? Y equals to 3 minus 3 square plus 2, which is 2. Any other values you like to try? No. How about some negative values? What do you mean it won't work? Can I have x to be negative values? Can, right? Give me a negative value to try. Okay, when x equals to negative 4, y equals to negative 4 minus 3 square plus 2, which gives me 51. Why? What's the issue? Huh?
Because when you square a negative number, it's not positive.
Okay, good job. What did you say? Put a negative outside where? You mean here? You mean here? Then you're changing the question already. You're not allowed to do that. Okay? Not yet, huh? Now, using this graph, using this equation, I don't want to change my equation. I see that I've got all sorts of values of x I can try. And I will get a corresponding value of y. Which of these is the smallest? 2. When did that happen? When x equals to 3. So what is the observation I'm going to make over here? What happens when you square a number? What are the possible results that you can get when you square a number? Only? When you square a number, you can only get positive numbers? Are you sure? And 0. 0 is not a positive number, right? What is 0? 0 is 1 minus 1 lah. Okay, let me put it on the board for you. When you square a number, the answer equals to, you were saying positive, right? Okay, it can be positive. Is that the only answer? It can be 0 as well, or 0. Okay, all familiar with this? Yes, in order to convince you, I've got, for example, -3, and I square it, I get 9. I try a positive number, 3 square, I still get 9. If I try 0 square, I get 0. You notice that no matter what I put, no matter what I square, I must get a 0 or I must get a positive value, right? Okay, so with that, let's go back to this. Remember, my goal is to get a minimum point. I want the smallest value of y. Y is going to be dependent on what you put in for x. Okay, inside this square over here, let me highlight it. Inside this square, inside this yellow highlighted part, can you tell me what is the smallest value possible? This is 0, are you sure? Can it be a negative? It cannot be a negative, right? It must be 0. That's the smallest value. And what happens outside the square? What do? To all of them? I plus 2, right? So if I want the minimum point, I must have a smallest possible value inside my square. Does it make sense to you? Yeah. In order to get the smallest possible value, that means inside my bracket, it must have a value of 0. And when does that happen? When does the inside become 0? When x minus 3 is 0, right? So what's the corresponding value of x? 3. And that is why, when you were doing this part, when you were telling me the line of symmetry, you were telling me that, hey, yeah, we just have to copy down the number inside the bracket, and we switch the sign. The whole process, by observation, you look at it and you tell me, hey, I observed that as long as I copy down the number, I switch the sign. It appears that I will be able to get my line of symmetry. Mathematically, what is happening? What are we trying to do? Yeah, we are trying to make the bracket be equal to 0. That is what we are trying to do. Once the bracket becomes 0, we have therefore obtained the condition for the minimum point, and that is our turning point. The constant at the end doesn't matter whether it is plus 4, minus 4, plus 100, minus 100. It is just a constant. It does not affect my x coordinate for the turning point. Okay, only whatever is inside the bracket affects. You understand? Okay? Okay, so I've spent quite a lot of time talking about the y-intercept, line of symmetry, and turning point. Last one, last column. Is it a minimum or a maximum point? How do we decide from here? How about if I want you to look at the equation and tell me whether it is a maximum point or a minimum point?
See outside the bracket.
See outside the bracket whether got negative or yeah, I hear that from some of the other classmates also. That's because you have already learnt it. But do you know why? No? Why? Hey, you cannot be going for whatever extra lessons you have, and then the teacher says, oh, the coefficient of x squared tells you whether it's a graph opening outwards or a graph opening inwards, and then just take it. You must know why. Let's see, Oh, if you learned it at Sec 2, then do you know why also? X squared minus 4. X and y. If I were to plot it out, -1, help me out here, -5, -2, 0, 1 and 2, -3, and this one? 0. Hey, something is wrong, right? 1 minus, okay. Okay, so this is what I have. Okay, I've got my x values, I've got my y values. Notice that when this number over here becomes big, so I extend to this side, if let's say it is 100, what happens to the y value? 100 square minus 4. Big number, right? It is very big. What happens if I'm lazy to think, okay? What happens if I go the other way? X and y. Let's say this is negative 100. What happens to the y value? Oh, big or small? Big or small? Let's try. Y equals to negative 100 and I square it minus 4. What do I get? Big, right? Okay, big. Okay. What about another equation over there? Then I do the same thing, but I skip some steps, because I think you can see where this is going. Y equals to x plus 5 square minus 3. So again, I've got my x and y values. X and y. Let's say I've got a negative 100. What happens to y value? Big or small? Can tell already, right? Okay, what happens if I got 100 over here? Big or small? Big. What these two graphs are trying to tell you is that as your x values become very small, as your x values become very big, we are going to result in both very big y values. Looking like this. When x is very small, y is very big. When x is very big, y still very big. Understand? Similarly for this, when x is very small, y is very big. When x is very big, y is very big. Then how do I therefore get a graph that looks like this? Let's try to make an adjustment. One very simple adjustment. I am going to change it this way. I'm going to put a negative sign in front of the x squared. Okay, what happens now to all the x and y values? Doesn't change? Are you sure? Okay, let's try for 0. When x equals to 0, what is y equal to? Negative 4. How about this one? 3. Right?
Yeah, I know, negative 3.
Negative 1. Oh, sorry. Negative 1 to 1. Negative 1. Negative 5 what?
Oh, yeah.
Right?
But there's no bracket. No,
Hey, stop making me doubt myself. Negative 5 over here. Negative 2 plus. This will be 0. Is this 0?
0, 0, 0.
Wait, no. Negative 2, 4.
No, but there's no bracket.
Negative 8. Hello? Okay? Now what happens when I go to a very big number for x?
Very small number.
One more time, you think through it. What happens when x is very big?
Very small. Flat. Very small.
Okay, I hear two answers. I hear two answers. One, it is very small. The other answer is, it is a very big negative number.
Very big negative.
Very big negative number.
Are they both the same? A very big negative number is just a very small number? Okay, so this will be small. What do you mean flat? So it will be 0. Oh, sorry, very small. What about this side? Negative 100 square minus 4. What will it become? Small. Okay? So what this means is that by putting a negative sign in front of the x square, it appears that when I have a very small x value, my y value is also very small. When I have a very large x value, my y value also very small. Okay? Simply by putting a negative sign in front of the x squared. Now what if I choose to put a negative sign over here? Okay, if I put a negative sign in front of the bracket, take note, listen very carefully. I'm putting the negative in front of the bracket, not in front of the x. Okay, negative in front of the bracket. What happens when I have 100 as my x value? Small or big? Small, raise our hand, small. Big, raise our hand. Okay, let me try to substitute. Y equals to negative 100 plus 5 square minus 3. This gives me negative 105 square minus 3. Negative 105 square, how much is that?
Big number.
Calculator, negative 105. Or 105 square?
11025.
11025 minus 3? Negative 11028. Big or small number? Small number. What about this one? Small. Okay, yeah, you're right. It's going to be the same, very small number. So this one over here, it gives us a parabola opening downwards again. When my x is very small, y is very small. When x is very big, y is again very small. Okay, what is the conclusion here? Can you please take a look at all the coefficients of x squared? Look at the coefficients of x squared. In the first one, what is the coefficient of x squared? 1. What is the coefficient of x squared? Third one, what is the coefficient of x squared? What do you mean don't have? What is the coefficient of x squared? Let me expand. This will be x squared minus 6x plus 11. Am I right? Okay, so what is the coefficient of x squared? 1. What is the coefficient of x squared over here? Coefficient of x squared? 1. All of them have a coefficient of x squared of 1. 1 is a positive number. Originally, this is what it looked like. When the coefficient is positive, I will result in a parabola opening upwards. Or like some of you may call it a smiley face. Okay, parabola opening upwards when the coefficient of x squared is positive. However, when the coefficient of x squared becomes negative, which is in this case, look at all these. The coefficient of x squared is all negative. We will result in graphs looking like this. All the sad faces, parabolas opening downwards. So is there a way to help us remember? Is there a way that you can remember whether it is a... Okay, yes, generally that's what students think. If you see a positive coefficient of x squared, it's a smiley face. Okay, a parabola opening upwards. If you see a negative coefficient of x squared, it is a sad face, a parabola opening downwards. And the reason I've explained over here, it depends on what values you substitute into x. And you see the corresponding changes in y. Okay? Is this a lot to take in for this lesson? Yes. Is it a lot? Yes. Okay. Okay. Now, I would like you to do this for your homework. Is it very difficult? You just need to go to decimals and fill in the blanks. Okay? Go to decimals. D-E-S-M-O-S. Fill in the blanks. Thus, you should be able to obtain conclusions based on the observations from the graphs, just as what we did earlier on for parabolas opening upwards. You will see that the flow is all the same. The reasoning is all the same. Okay? Then next lesson, I will tell you my approach to sketching them based on the 4 items over here. What is the x-intercept? What is the y-intercept? What is the line of symmetry? And finally, what kind of point is it? We are going to fill out this blank. It's going to be either max or minimum. Okay? And you should by now have an idea of when it is going to be a maximum point, when it is going to be a minimum point. Okay, so any questions for this lesson? No? We should have 2 more EMATS lessons before we go back to our AMATS. Okay, just 2 more EMATS lessons. We are finished with EMATS for the test. Yes. Sorry? Yes. This one, go. Okay, class. You know, after you've been through this lesson, there seems to be, I think there's a lot to take in, to absorb. The remaining 1 minute, I want you to take time, think through what you have learned. Because it happens, okay? During the lesson, right, you may know what is happening. You may be able to follow, yes, this makes sense. Ask you to do it by yourself, you realize, how did this happen? So take some time, absorb everything, consolidate, internalize it before your next lesson. Ken, you may even attempt to do page 67 right now, based on the approach, the thinking process that I've covered earlier on. Yes? Sorry? Not exercise one. I'm only giving one piece of homework, which is to fill in the table on page 67 for now. If you have any queries, please raise your hand. I'll come to you. Sorry, I forgot the phone to hit.
What is it talking about? Thank you.
Oh, it looks like you have decided that your file is going to be purple. Have you decided? I don't know what you decide. I want to see my first complete mouse today. Okay, what's that?